Okay, I want to welcome my fourth period to the YouTube world. Yay. Moving along with the second section of fourth quarter, we're going to say, let's get creative and do it my name. To graph an equation, now we have equations again, and when I was doing the grading the test, there's a lot of situations where you guys will use the inverse operation, but whenever you have a situation like this, what you would do is you guys are adding 4a to both sides. Is this a positive or a negative 4a?
Negative 4a.
It's a positive 4a. Okay? It's a positive 4a, and that's just a general concept that I want to make sure that we're not making that mistake again because we're getting back into equations today. So to graph an equation, we must solve or substitute each value for x into the given equation. We must substitute each value of x into the given equation. An equation like y equals 2x plus 5 is called a linear equation. It's called a linear equation because the graph of it is a straight line, as in linear. It's a linear equation because it's a line. So they're going to find four solutions by substituting a value for x into the given equation. Now here's one of the situations about this unit is we're going to be choosing our own values of x that we want to use. I would recommend using a value that is small. Okay, using a whole number that is small or something that will make it easier on yourself. And I know that this group loves to make it easy for themselves, right? So now it's going to be a good thing to do that because if you were to use a number that's really, really big and substitute that in for this value of x, that would be a big number. So let's keep it a small number. So I'm going to recommend that you would do -2, -1, 0, 1. Or you could do 0, 1, 2, 3. Now what I'm going to do is I'm going to substitute that in for the value of x. So what's happening is I'm going to take that value of x that I just made up, that's right, we made it up, and put it in there, okay, and plug that in there. And I'll tell you why in a minute, why we can just choose whatever number we want. Because it's math? So we have y equals -2 plus 1, because I'm taking this x and putting it into that value. Does anybody have any questions as to how I got what I wrote in green? Okay. You know, let's just do all these right now. -1 times -2, -1 plus 1. Y equals -2 times 0 plus 1. Y equals -2 times 1 plus 1. All I'm doing is substituting in the value of x that I made, and that's negative red. So this guy here is just being substituted for those. Now I'm going to evaluate it. So I have -2 times -2, a negative, or negative times a negative is positive. So 4 plus 1 is 5. -2 times -1 is just 2, plus 1 is 3. Y equals -2 times 0, anything times 0 is 0, plus 1 is 1. -2 times 1 is -2. Plus 1 is -1. That's another thing about the tests. I don't know if you guys noticed that. Hopefully I pointed it out. But there was a lot of times where people would have a Negative 6 plus 5. This was number, like one of the last ones. One of the last ones on the test. But what was happening is you guys were having negative 6 plus 5 be negative 11, when in fact it's just negative 1. So the solutions, yes, ma'am. Yes. For this part, yes, but I'll show you how I'll know right away. So we have, look at this. We have an X, we have an X, and we have a Y. What have we been doing with X's and Y's? We've been graphing them. So we are going to have the solutions be, we take the X value, negative 2, and we put in the corresponding Y value, 5, negative 1, 3, 0, 1, and finally 1 and negative 1. So we're just taking the X values, putting that in for the domain, and we're taking the Y values and putting that in for the range. So what I just said there puts in yesterday's lesson. Now let's put in what we learned about in that extensive lesson on Friday, right? Or Thursday, the plotting points. I go to 2 or negative 2, 5. So I'm going to go 1, 2, 1, 2, 3, 4, 5. Just put a plastic. Thank you for helping slow down us ruining this world. Negative 1, 3, negative 1, 1, 2, 3, 0, 1, 0, 1, negative 1, sorry, 1, negative 1, 1, negative 1. So I plotted those points, so that brings together the last 3 lessons that we've had. Yes, sir? I'm going to show you right now. I see a lot of you guys turning the page, but we have to do something first. I want you to take your school-issued straight edge, and you are going to draw a line that goes through those points. And that's not going to work, Smith. I made it really thick and... I'm going to go red. We're going to go there. Oh. Sorry. And this is technology, so it's not going to go exact. There we go. So I drew a line. Now, all of you are going to have different results if you pick whatever number you want. But any point that falls on that line is going to be a solution. It's going to be a solution no matter where you put it. So no matter what number you put, it would end up on that line. For example, if I were to go backwards now and look at it, I'm going to try to see if x is 2, y should be 3 if this is showing up right. So if x is 2, y should be 3. Negative 2, 2, plus 1. So we have 3 equals negative 4. Oops, I meant to say negative 3. Plus 1. Is negative 3 equal to negative 3? So it fell on the line. No matter what, it'll be on that line, no matter what number you choose. Now, what else do you notice about our numbers? Did all of our solutions fall within our coordinate plane? That's because we used small numbers. If we used a big number, if I would use something, 20. Let's try 20. So 20 for x would be y equals negative 2 times 20 plus 1. Y equals negative 40 plus 1. Y equals negative 39. Now, that would be, since it's a negative 39 on the y, it would be way over there, and it would be somewhere. Come on. Get out of there. Thank you. It would be somewhere up here, and we don't have room for that, do we? That's why you want to keep your numbers small. Aren't smaller numbers easier to deal with anyway? So, yay! All right, get this out of here. I agree. Let's do another example, and we'll see. Okay? Let's do another example, maybe just to give your brain a little bit more time to wrap around it. So we are going to choose small numbers once again. 3, 4, 5. Yeah, let's try it. 3, 4, 5, and 0. Combo breaker. Combo breaker. So I'm going to just substitute these in here. Y equals 3 plus 1.5. I don't know why I'm singing so much. I'm trying to keep myself awake. Huh. So I just inserted these numbers. I substituted the x values in for x. Now I'm going to solve for those, and these are some pretty tough decimal questions, so I'm going to, rather than putting you through the mental strain, I'll just go ahead and do it. So we got 4.5, right? Because these are so tough, right, guys? Yeah, so it's over now, so you can just write those down, because I know you guys all didn't already. So we have 4.5, 5.5, 6.5, and 1.5. Ooh, that's a good question. So we have a student noticing that we don't have those 0.5s in there. But let's write down the solutions. Let's write down the solutions first. We have 3 and 4.5. We have 4. Please stop with the additional commentary. Mm, 5, 6.5. Ooh, that's a good concept. 0, 1.5. Now for graphing the equation. And for YouTube reasons, I'm going to zoom in a whole bunch, but you guys will still be able to see the coordinate planes, but I'll repeat them as well for those of you who are at home and, hey, maybe aren't even in my class, because I know that there are some people from California that were watching my video a couple months ago. Okay. Yeah. So what is the first solution that we wrote down?
3 plus 1.5.
Okay, let's try that again. Can I have somebody please raise your hand and tell me? Ella? 3 and 4.5. So I go 1, 2, 3, then 1, 2, 3, 4, and halfway up. I go 0.5 because whenever we have a line, graphing on a line, if you have a 1 and a 2 and you have 1.5, you'd go halfway. You would go halfway. And the next solution? And the next solution is? I can't see it, so I need someone to raise your hand and tell me. Don Weiler.
4.
So it's 4.
4 and 5.
1, 2, 3, 4, 5 and a half. So that's 5, 5 and a half. 5, 5.5. So when you're saying it out loud, you can say 5, pause, 5.5. How about the next solution, Kat?
5 and 6.5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6.5. I did say that. I misspoke. Thank you. Yes, sir. What's the last one? 0 and 1.5. 1.5. So if I have done this correctly, I should be able to draw a line. Yes. I should be able to draw a line and hit each line. If there's a situation in class when you have one like right out there, you know which one you messed up. Because if you're doing this correctly, it'll all fall on the line. And if you got stuff going on every which way, that's when you need to see me in the morning. Okay? What if we tried 3.5?
Like, no, like, what if we did, like, what if we didn't do, like, 3, 4, 5, 0, like, we do, like, 1, 7, 8?
8 would not be on there because it would go beyond 9.5. So you try to pick a number. So Kat just had a really good question. What if you pick a value for x and you accidentally go off of the graph? Choose a smaller number. Choose a smaller number so you can demonstrate it. So not redo it. I mean, it's only just substitution. It's not like you're solving an equation yet. Yes?
Not numbers that are in order like 55, something like 6, 2, 1, and then 0. That's still following the line there.
Yes. Yep. As long as you're doing it correct, no matter what you choose for x, it will land on that red line. And see how it points arrows up? That means it goes on forever. Don Weiler.
When we did the X numbers, do they have to be, like, 3, 4, 5, or could it be, like, 2, 5?
You can do whatever you want. Just make sure that your y value and your x value are going to stay on the map that you can see. Yes? As long as you evaluate it correctly, it will stay on the line. It will stay on the line. And on the homework, there's only 3. Find the solutions, determine. There's only 3 that you have to graph, and the numbers aren't there. So you choose whatever numbers, values you want. Yeah?
What if you choose numbers that are like negative and positive?
Still the same thing. Let's do it. Question was, what if we choose a negative? Actually, we chose a negative number right here.
So no, say if you go like -1 and then pop out.
Yep. Because see how it goes into the negatives as well? Whoop, what? Okay. Next one. Find 4 solutions for the following equation. So let's choose small numbers because look at this. See how we have it's going to be a product of that? See how it's multiplication? We want to use really small numbers. Kat? -2. Okay. Yes, what you want? 3? Cool. Phoenix? 4? 2. 4, 2. And can you give me a can you give me another negative number? -5. Okay. So we have 2, or -2, 3, 4, 2, and -5. So let's evaluate those. So everybody go ahead and do that. You've seen me do it a couple times. I would like you to do it. I'll do it at the same time. If you're uncertain, go ahead and look up. Kat? Yeah. Only if you're doing math correctly, though. Thank you. Because I wanted to write out the arithmetic so I didn't make any mistakes. Because all this is right here is that? You Okay, the y goes off because our y would be a -9, and our graph only goes to -8. So we would, if this is our homework, we would have to redo a couple of these, wouldn't we? But however, here's the thing. Is it still a solution that we have -2, -9? Okay, so the question is asking us to do one of the solutions, -2, -9. That counts. That's cool. It's all good. Three and 1. 4 and 3. 2 and -1. Yep, and -9 goes off the grid. And so does 15. Yep. But let's plot these points and see what happens. Huh. -2, -9. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. 3, 1. 1, 2, 3, 1. 4, 3. 1, 2, 3, 4, 1, 2, 3. 2, -1. 1, 2, 1. Let's see. How did we do? Find out when you tune in next week. Not bad. Not bad. So that's where it would go. Yeah, it was close. Look how close it was. How many points do you really need? How many points do you need to map the line for the solutions? How many points do you need?
At least 4.
Yeah. 2? Yeah, in fact, you need 2. They're asking us for 4, and that's why every time it's always going to tell you how many that you need. Okay? How many that you need. For example, my old house, when I was building a fence, all I needed to do was make sure that, okay, here's the side of my house. All I did was I put a stake toward the front of the house. I put a stake right here. And then what I did is I took a string, tied the string to this stake, and went way down to the back of my yard to make sure that the fence was going to be parallel to the side of my house with the garage. Because all I needed was 2 points to make a straight line. I love geometry. I'm apparently singing today. Actually, I do have a friend on Broadway. She's Jasmine in Aladdin in New York. Yep. Yeah, she's actually, I mean, her Instagram and it's ridiculous. Like all these beautiful people and big events. Find our solutions for the following equation. I don't know if we're going to do this one. Let's see. Is there anything special about this one? All right, you know what? We're going to Smith this one because this is the exact same concept. The next one, however, has something different about it. The only thing different about this one is, there's a negative in front of the x. So does anybody remember what another word, and don't say minus, does anybody else remember the word for whenever a number is negative? Like if I want what's another way of saying -5? Yeah.
Another way of saying -5.
Yep. Does anybody remember?
-5.
I said don't say minus. Yeah. Don Lyler? No, is that a hand up or you just like, oh, just kidding, just rubbing my brow. Got him. Yeah. No. Opposite? You've heard me say that, right? The opposite of 5 is -5. So whenever you have your negative in front of your value, that means that whatever value of x it is, it's the opposite of that. So what's the opposite of -15? 15. What's the opposite of 14?
-14.
-14. Good. Good job today, everybody. You're doing really well. I like it. I like it. Graph the equation by plotting it. That's Smith. That's still Smith. Find 4 solutions for the following equation. So we have multiplication again, but here's the thing. We don't have it being equal to y, do we? So when we plug something in for x, are we going to come out with a y? Now. So we are trying to get y by itself, so I must put into standard form. And guess what? We are going to put a star by that, and that's something that you are going to be asking me about if we have time to do our home. No, we don't. If we had time to start, be like, I don't know what to do here. I'm like, look at the star on your notes. We need to put it into standard form, so we need to get y by itself. Negative 3x plus y equals negative 5. We have a negative 3x that we need to bring to the other side. So how are we going to make it go to the other side? So say the first thing you said again. 3 what? There we go. We're going to do plus 3x to both sides. So now we have y equals 3x minus 5, or you could have negative 5 plus 3x. It's the same thing. Now I can put this over here. Y equals 3x minus 5. So we have to make sure our equation is going to equal x, so we can have it be the form that we like. Yes, ma'am? There are 2. On the homework, there's only 1 that you need to do that. Hi. There's only 1 that you need to do that. Okay? I can print this out for you as soon as we get done with these notes. We're on the last one right now, so you can copy it. So now I have values of x. I want to keep them, let's keep them small. I'm going to do the standard thing that I like to do, because it would be negative 1, 0, 1, 2. I'd like to have 1 negative number in there, A, because it's good practice for the park test, and 2, that way I'm making sure that I might be getting into the negatives for my y. It makes it more of a chance to do that. One moment, please. I don't want to make any silly mistakes like I did before. Okay, what's your question? No, when you add 3 to negative, or when you add 3x to negative 5, it's 3x minus 5, or negative 5 plus 3x. Yeah. Just 1. There was supposed to be originally 3. That's why we started doing the finals. Yep, just 1 park test this year. So now I have y equals 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8. 3 times 0 is 0. Minus 5 is negative 5. 3 times 1 is 3. Minus 2 is what, everyone? 3 minus 5. Negative 2. Thank you. I might be moving a little bit quick while you guys might have been writing. And the next one we have, 6 minus 5 is 1, exactly, not 11, like a lot of you did on the test. It's not. There was so much focus on the new stuff that we forgot about integers. Yeah. But that's why this stuff keeps coming up again and again and again and again and again. Yep. Negative 1. The first solution is negative 1, negative 8. The second solution is 0, negative 5. The third solution, 1 and negative 2. And to remind you, where I'm getting these numbers is from the x and y values of each part of the graph, or each part of the table. Next final solution that we wrote down and found is 2, 1. Let's get through this. I can answer those questions in a minute. I want to try to keep these YouTube videos as short as possible. Negative 1, negative 8. I take my number and I start at the origin, and I go 1. Negative 1. 1, 2, 3, 4, 5, 6, 7, ooh, 8. Get me close to there. Next one, 0, negative 5. 0, negative 1, 2, 3, 4, 5. Salud. Lots of sneezies. Next one, 1, negative 2. 1, 1, 2. Next one, 2, 1. 1, 2, 1. Yeah. So we got our line in there, and we are set and ready to roll. Are there any questions? Okay. My new YouTube capturing class, say bye YouTube.
Bye.